and welcome to Calc Lab. Today what we're working on is the derivative of our inverse sine function. And we need to discover what this derivative is. We don't know right now. And so an exploration in calculus requires a little bit of experimentation, which relies on creativity. So we don't know what the derivative is. We might start with something like a statement: y is equal to the inverse sine of x. What to do with that? Looks like we're looking for the derivative. I like what you're thinking. You're thinking implicit differentiation. Well, I'm thinking the same thing. And this is that part of the experimentation process we just have to allow ourselves. There we are. Now what I'm going to do is on this side, I'll say this is the derivative of y with respect to x. And over on this side is that derivative. Well, that's about all I know right now. What I'm going to do is I'm going to come over to this side, taking that very first statement that I made, y is the inverse sine of x. And what I'm going to do, I'm going to write the relationship that I know. When I have a statement like this, I was not able to find the derivative of y with respect to x. I know it's stated here, but all I've done is just restate what we're looking for. So off to this side, what I'm going to do is I'm going to write sine of y. See what's happening here. Sine of y is equal to x, like so. Now again, we'll differentiate with respect to x. And maybe this will get us further along than we were able to get over here. Now we'll notice that the derivative with respect to x of sine of y, I might treat it like that language I used in class, the derivative of sine of garbage. The derivative of sine of garbage is cosine of garbage. Times the derivative of the garbage, which is dy dx. Now over on the other side, the derivative with respect to x of x is equal to 1. So we'll just have a 1 right here, which is pretty convenient for us. Now our job is to find dy dx. And we do have a statement now for dy dx. And it is this, at least so far. The derivative of y with respect to x is 1 over cosine of y. But what I would like to do is I would like to have a statement of the derivative of y with respect to x explicitly in terms of x. So what I'll do is I'll just explore some things that I know so that I could find the derivative of y with respect to x. I'm going to move down here. I have a little bit of scratch room, place for scratch work. And I'm going to take something that I know that you know. And what I did is I wrote down the Pythagorean identity, sine squared, whatever the argument is, plus cosine squared, whatever the argument is equal to 1. In this case, I wrote the argument of y so that I could take a look at what cosine of y could be replaced with. I'm going to subtract sine squared of y from both sides. Then take the square root of both sides And I'll keep the principal square root, the positive one. Because I'm dealing with the inverse sine of x, I know that the cosine of y is going to be positive. So now that I have this statement here, cosine of y could be replaced with this. But one more substitution we can make, and I think I have just enough room here. Remember that sine of y is equal to x. What if I squared both sides here? Sine squared y would equal x squared. And it is that substitution that I could make, since sine squared y is equal to x. I actually have the derivative of y with respect to x. Let's just put it together right over here. Found the derivative of y with respect to x is 1 divided by what was cosine of y turned into the square root of 1 minus sine squared y. But sine squared y turned into x squared, so we end up with 1 minus x squared. Look at this. We were now able to discover. We didn't look anything up. It was all in our heads right here. We certainly need to know trigonometry and enable for us to follow along with what we've done. So review your trigonometry if you need to. This good old Pythagorean identity came in pretty handy here, and we were able to state the derivative of y with respect to x. I think what I'll do is I'll erase my scratch work and make a more formal statement. This is what we were looking for here, the derivative with respect to x of the inverse sine of x. Here's our proof. I'm just going to state a little therefore. The derivative with respect to x of the inverse sine of x, let's put some square brackets on here to make it look nice, is equal to what we have found right here, and that's a keeper for us. This is something that we certainly want to know moving forward.